In this lecture, we're going to see about infinite series. So, infinite series. So, an infinite series is of the form. Let's say if you have a series like this. So, un is summation. So, we have a series this way where the series is nothing but summation over running over I going from 1 to infinity, and the series is ui, let's say xi square. So therefore, the terms in the series will go like x1 square, right? So x1 square plus x2 square plus x3 square, and it will go up to infinity. Okay, it will go up to infinity. So this is an infinite series. Now you've studied this kind of series in your lower classes. You would have studied about an arithmetic progression. You would have studied about a geometric progression. All these things. So these are all infinite series. So in our case, we are going to see the sum, whether the series is diverging or converging, whether the given infinite series is diverging or converging. So if the sum if the sum of the if the sum taken up to infinity, okay, if the sum of the series taken up to sum of the series where n is going up to infinity is finite. Finite means you get a definite answer, you get a definite number. If it is finite, then series is convergent. And series is convergent. If the sum taken up to infinity, n number of n going to infinity, if it is taken, if it is infinite, then it is a diverging series. Okay, it's a diverging series. So this is convergent. This is a weak view. Handwriting is here. Convergent. Okay. So let's take an example and see. There are different kinds of tests to evaluate whether a series is diverging and converging. So the first kind of test we will see is called the comparison test. Comparison test. So in a comparison test, what we'll do is we may be given a given series. Say we are given a given series u of n. Okay, it can be any series. Okay, it can be any series. Now, what we'll be asked, what we will do is we'll take another series that we know is convergent or divergent. So, for example, we'll take another series that we know is convergent. Okay, and we'll take their ratios. If the ratio is equal to 1 or less than 1, then it is a converging series. So we'll take the ratio u of n, v of n, the nth term of the series u of n and the nth term of the series v of n, and if the ratio is 1, okay, actually the ratio need not be 1, the ratio just needs to be any finite number. Okay, so if you are taking this series to be, so if you get any number, okay, so if you get, so, if you take the nth term, okay, so 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 if you get any number, 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 okay, so if you of both the series, and if we take the ratio and if we get any number which is finite and non-zero, then both the series converge or diverge together. So that is, if you are taking the Bn series to be a convergent series, then the Un series also will converge. If you're taking Bn series to be a divergent series, then if you get a finite answer, then Un also is diverging. So then Un and Bn converge or diverge together. Okay, so let's take an example and see how this works out. So we are given the given series here. Here given Un is nothing but summation square root of n square plus 1, where of course n is running from where if, the sum is over n. Okay, the sum is over n, and this is the nth term. And then we have another. We have to take a series to test its convergence or divergence. So we'll take a convergent series. A convergent series. Now, just tell you this: any series which is of this given form is actually convergent. So you can use this to test your. You can use this in a comparison test. So if any series of this given form summation 1 by n raised to the power p, where p is greater than 1. So this series sum is over n. So this series where p is greater than 1. So the power of n is greater than 1. So it can be n square, it can be n to the power 3 by 2. Any such series is convergent. Okay, so it's a convergent series. So the series I'll take here is to test with this is 1 by n to the power of 3 by 2. Or this can otherwise be written as, this is equivalent to writing square root of n divided by n square. So this is equivalent to writing this. So now let's take Un by Vn. So Un by Vn is nothing but now square root of n divided by n square plus 1 divided by Vn. So I can multiply by the reciprocal of Vn. So which is nothing but n square. So this is nothing but n square plus 1. So now what we can do is we can divide both the numerator and the denominator by n square. Okay, divide both the numerator and denominator by n square. So this just becomes, numerator will become 1, denominator first term will become 1, second term will become 1 by n square. Now this has to be obviously evaluated in the limit n going to infinity. Okay, so n going to infinity because it's a infinite series. So this 1 by n square will go to 0. Okay, this 1 by n square will go to 0 and you'll get a finite answer 1. So therefore the Un series now, because we are getting a finite answer and Vn is a converging series, Un is a converging series.